my calcium. So, let's not forget my calcium. Okay? Don't forget those. Now, as we begin to see the muscle relax, we're going to see that the numbers that could be measured are going to change. I'm going to have those pluses go out, minuses equal back out. I'm going to repolarize, and then my cell is going to go back to rest. What do you think? Have you ever done this?
Yeah.
You did?
I mean, well, it's just the first time.
Inside?
Yeah. We didn't go in the nerve.
In the brain?
You want to work in like the cardiac version.
So, I'm wondering if it is important to the medications that be used to affect the activity of the nerve.
Yes, it's on certain.
Hold on. Do what?
We talked about all the types of neurotransmitters and proteins, serotonin, and so forth.
And then the activity of whether they're active or too active. Cool.
But there's only certain medications that go across the barrier in the brain.
Well, now, you'll talk about that more in part 2, and the way that that happens is really interesting. How they make medication to cross the barrier of the brain. It's really interesting. So, this is going to be termed an action potential. But right now, I've only represented it based upon one muscle fiber. Okay? So, we're looking at it based on that one fiber, how those ions are going to be moving across that membrane, the different channels that we're going to see that we need. So, one of the things that I said about the movement was that this passing of the ions, that it needed to occur all the way down the length of that muscle fiber. I'm still talking right now at this point about one fiber. But remember, if the activities that are taking place at the one fiber are occurring at every one of them, that's going to make the whole muscle do something. How is it that once we get the action potential started, that it moves the length of the muscle? It propagates. What? Ever heard that? Propagation. Okay, I know I've heard it used in some way. It's just that for the life of me right now, okay, y'all can all identify where your brain just gets to a point and it just, I'm done. Okay? Y'all get to that point, right? Okay? So, I don't know. I did have somebody tell me some jokes. Okay, so I'm kind of, like at that point, when my brain is just like, I'm done. I'm out of here. Okay, I just can't remember how I heard that term. All right, but I can tell you what it does. It's really kind of cool. Okay, remember, as we look at the structure of the muscle. All right? Let's take apart. One of these days I'm going to make a fiber. Okay? That's what I might do over the summer. I might find some way to make me one little muscle fiber. All right? I got to get down on the part right now. And we've got some. Tried that one time. Didn't quite turn out the way I wanted. But that's okay. My brain's good. Okay. So, we think about that fiber. Okay? Remember, we've got sarcomere, after sarcomere, after sarcomere, after sarcomere, after sarcomere. Each one, Z disc, Z disc, Z disc. We got all those other lines that are present, like the midline, okay? The goal, when the muscle contracts, is that overlapping actin and myosin. They do this number. When it relaxes, they do this number, okay? Think of each one of those sarcomeres as a piece. So we have piece after piece after piece after piece, okay? I've got the nerve that comes in to the one point. But then I got all the pieces going along each side. Now, do you remember how in the structure of that fiber, we've got that sarcoplasmic reticulum, we've got the T-tubules, all that sort of stuff. So once I get it started at the point where I've got all of my ligands, and if I've got piece after piece after piece after piece after piece after piece, okay? Sarcomere, 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 all the way down, okay? If I have my point where the action potential starts, if you look at it this way, it's going to travel the distance. So right here is going to activate voltage gated, voltage gated. These voltage gated open. I change my minus to positive. That means these voltage gated are now activated. I take my minuses to plus. Now, if that's how it's going to occur for every single piece, like if I had board all the way out here, okay, I would just continue to draw a couple more sarcomeres. This voltage gated action acted on this one acts on this one, and so forth. And that's going to occur all the way. Now, as I go from negative to positive, and then this section begins to go from negative to positive, here's what's going to happen as it travels, as it propagates. Once this one gets started, this one right here, those sodium-potassium pumps start working, and as this one becomes positive, this one starts getting returned to negative. As this one becomes positive, this one will return to negative. As this one will get positive, that one would become negative. Do you see how that means propagation? Because as I go from section to section to section, the one previous will start returning to negative. This one will positive. This one will return to negative, positive to negative.
So that threshold is only reached at the first when you're on contact level.
Actually, it's got to make every one. Well, now the threshold, yes. And the stronger it is, the more influx of the ion. So what this is doing is as it's moving down that fiber, okay, as it's allowing the previous section to go back to being negative, it's helping me go from depolarizing my cells to repolarizing my cell and letting my cell go back to rest. In skeletal muscle, how quickly would the passing of these ions occur? Quickly? Millisecond? Yeah. Because if I'm walking along at night, okay, I got a little light on somewhere, and I go boom with my toe right on the edge of the table. You know, that fun little activity that takes place that probably not end up being very pretty. Okay? You don't stand there and be like, oh, ah, okay? When you get ready at 3:15, break time, all right? You're sitting there, all right? I say, okay, break time. You got to 3:30. You don't do this number. You don't do that. It's occurring quicker. So this ability for it to contract is occurring within milliseconds. Very quick. It's a very quick activity that's taking place. So we're going to see it travel. And the one thing that we have to have, okay, for skeletal muscle contraction to occur, we have got to have the action potential from the nerve. The area of the neuromuscular junction is extremely important. There are diseases that take place at the neuromuscular junction, and it affects the entire activity of that cell, of that muscle. The neuromuscular junction, what we say about this, we have our area of the synapse, the cleft, okay, where it is actually like space, okay, and an empty space, all right? Now, at this movement, okay, when we are talking about the neurotransmitter, the only neurotransmitter present for muscle contraction is acetylcholine. That is not our only neurotransmitter in our body. Okay, there are others, all right? But acetylcholine for skeletal muscle is a neurotransmitter. We are going to say that at this neuromuscular junction, we have a presynaptic terminal. Presynaptic, before the synapse. Does that make sense? We have our postsynaptic, after the synapse. All right? The cleft is our space. This is giving us an idea. This is have y'all ever heard of like the scanning electron microscope, the transmission electron microscope? Okay. This is scanning, showing us the connection from that terminal end of the nerve to a fiber. All right? So, when we begin to look, don't forget that we've got our other components of that muscle cell, especially that sarcoplasm, because the sarcoplasm contains the calcium. Okay? Now, when